I mentioned last week, well, we had a lot of people gone, and I know some of you were here on our Teams meeting. So today we'll have the files that we created last time. I have them zipped up, so I'll show everybody how to copy them over. So it's not a problem if you weren't here, didn't have those, whatever. We will recover from that. But before we do, I wanted to remind you that there is a lot of training available. Now, sometimes people will say, you know, I found it on this side or that side, or I watched this video or that video, and that's always so great because there's so much training available online. Remember, the training that I've provided to you, like your textbook and the videos that are posted on Canvas, should be your first training source, and those things are going to kind of get you geared up to finish the assignments that you have. If you then feel like you need more information, which is totally understandable because you're learning like a lot of stuff, not just a new language, kind of a new way of thinking depending on your background. So there could be lots of still areas of confusion. Remember, there's lots of training available online. You can get to this actual page in Teams, but I'll post these 3 links. These are just from real quickly searching for C# classes. The top one is Microsoft's site, and they have a couple of different formats you can use for complete training material on C#. Really good stuff. Tutorials Teacher is a really good site. This C# class page that they have just starts with a real basic class and shows you how to create it, kind of like what you're going to need to do for the trip class for the assignment that's due Wednesday. Then the W3 Schools section on classes is a little bit more spread out. You know, they have this page that explains this part of it, and you click next and you can go through a lot of different information on working with classes. They all look different because, remember, creating classes in C# is creating our own data types. So it's completely flexible. So that means that you can find an example that does something one way here, and you can find an example that does something in a way that looks completely different to you at first someplace else. So look at all those examples, you know, try to find an example that's close to your objective so that you can use that as a good template to get started with. And whenever we started last week, I told you this is the area that has a really steep learning curve, you know, depending on your background. Can feel like one of those mountaineers, like you're climbing that face that's just straight up while you're trying to get some of these concepts stuck in your head. And that's okay, that's to be expected. So that's why there is so much different training available. And there's so much available online because so many people are trying to learn. So there are several videos in my YouTube channel that aren't listed even in our Canvas document that go through creating different types of classes just over the years, the different semesters of trying them. So lots and lots of material available. For us, looking at where we are, I'm going to bring this Canvas thing over. We're still working on the Lesson 6 material. The REPO course is due tomorrow night. The trip class assignment is set to be due Wednesday morning. To kind of key to you, that I'd like a few people to present that Wednesday morning. So we'll probably ask for maybe one presentation from each group of how the trip class was created. So we won't want a whole bunch of them, but we'll ask a few people to present that Wednesday. That might be something that you have to really, like I said, find a website online that is somewhat similar to that so that you have an example. It might be something that is just super easy to you and you don't have to worry and you just put it together. That's great either way. But we're going to be starting on our next section, on Wednesday. So Wednesday, we'll look at some of the assignments for this trip class and then get started on lesson 7. And in lesson 7, we'll be looking at .NET types that are available that are more complex than the things we've been looking at so far. All right, so I told you I've got files. So if you would, on Teams, under our class team, in our meetings channel, if you click on files, you should see all of the different files we have for our meetings. And I've got a couple chapter 5 files out here. Let me get some of our tardy people marked. So are you Devin or Archer?
Devin.
I thought, but I don't want to mess with it. So I'm changing the wrong one. Okay, that's everybody. Okay, so we're in Teams. We're looking at our meetings channel, and we've clicked on files up here at the top. And here we see there's our recordings folder that has all our recordings from class. And then here's a couple of new files. Well, I want you to grab this one, chapter 5 with combined.zip. So select it, and then you want to download it. The way Teams does its downloading is a little weird. So I'm going to go to my downloads folder. I'll open File Explorer. And go to my downloads folder. And you want to make sure that it's finished downloading. It's kind of hard to tell. I'm going to double check and see how big it is. It won't tell me there, so I'll just hope it's done. I have about 375 kilobytes. How's everybody else? Is yours that same size? If we're all the same size, I think we're good. So now I want to extract this zip file because I want to be able to access the files that are within it. Archer, we're downloading the files that we created last Wednesday, so please get these with us. Okay. Make sure you guys are on track here, getting this taken care of. I've got my chapter 5 with combined zip. I'm going to right click on it and extract all. And I'm going to extract it to my code folder where I keep all my Visual Studio code. So let me browse to that. And I'm going to select my code folder and extract. And I have that little checkbox checked that says I want to show my files when complete. But I don't want it to replace what I already have. Let me hang on. I've got to rename my existing chapter 5 folder. So you might want to extract this someplace else. In this folder, we have 3 projects. So once you get that zip file extracted, you should see that it contains a folder named Chapter 5. And inside there, we have the 2 projects that we created last time, the Packet Library project and the People App project. And if you remember, we created the Packet Library project that contains our person class. And our Packet Library project is a class library. We could also call it a DLL library. That's what you'll hear some programmers say. Let's go look inside of that project folder to see why we call that just a class library. So in Packet Library, if you open it, we see the files that we normally see in code, our .cs file and our CS project file. We've fiddled with both of those a little bit, our project file less than our CS file. We know our CS file is where all our code is. Well, whenever we run an application in Visual Studio Code or Visual Studio, our C# code gets built, gets expanded, and turned into an intermediate language that the computer can run. And that intermediate language is saved in this bin folder. Some people call it bind for binary. Now, inside my binaries folder, I see a debug folder. And if I open that and keep going, I eventually will find the DLL for that project. It was a class library. That means that we didn't have any user interface. It only had a class file in it. And when we compiled or built that, it became a DLL, which stands for Dynamic Link Library. So now I could use that Dynamic Link Library, that person class, wherever I want. I could use it in my People app that I created. I could use it in human resources and in payroll and in all sorts of different places because I have that template now for what kind of information I want to keep track of for a person. Okay, so now I want to go back to my Chapter 5 folder with all those extracted files. And I want to look at the bin folder for the People app. In my People app, remember, I actually created my tester. My program.cs tries to create an instance of my person class. We'll look at that some more today, but I want to see what happens when this project gets built. It's not a class library, it's a regular project. So if I go into my bin folder and debug and .NET 5.0, I find an actual executable. And the .exe file is what's running when we run our code. So here that I'm in this folder, I could run this. Oops, Windows is going to protect me from it. I'll have to click more info and say run anyways. I trust them. I created it. And then nothing happened, so voila. We should see a console window, but that's all right. I would be able to see it better, maybe, if I opened a command prompt here. If you click up there in your address bar and type CMD, that will open a command prompt window right here at this folder location, kind of a terminal window. Now I'm looking at that folder and I can actually type the name of my executable, People app. And then I actually do see my output from that People app application, if you remember. So when I create a class library type project, I'm only expecting to generate a DLL, to build a DLL, a dynamic link library that I can use in other projects. When I run a console project or another type of project that has a user interface, it's going to create an executable file that I'll be able to run. Okay, I wanted to show you those while we were looking at how those two projects were fitting together, because I created a third project called Combined. I'm going to open it. In the Combined project, I put our person class and our tester together in the same project so that we can do some debugging and see what's going on with those things. So we're going to veer off a little bit from the way our textbook does it, and we're going to open this Combined project. So let's open Visual Studio Code. And I want to open that Combined project. So I'm going to close the whatever I have open. Now, everybody okay? You've got the file extracted and can find our Combined project to open. Y'all good? Now, when I'm opening Visual Studio Code, I'm getting this message down here about projects having trouble loading, but it's not seeming to cause me any trouble. If I look at the output, it says that it was attempting to update my project file that wasn't loaded yet. So I don't know why I'm getting that error, but it's not causing me any trouble. Now, before I do anything, I want to look at the code that I have. Let's look at our person.cs file. Let me make mine look like, does yours look just like this? Okay, good. So in our person.cs file where we left it last time, it did not have these lines 11 through 15 in it. I've added those, and we'll be changing them as we go to follow along with our textbook. But let's add some comments to that. So right before line 11 here, I want to press enter to open up some white space. And I'm going to put a comment that this is the constructor. And a constructor is a special kind of method that is used to instantiate a class. Remember last time when we were looking at the spheres, we saw that instantiate means to create an instance of a class. And whenever we do instantiate our class, create an instance of it, which we do in our main method, we'll go back and look at that here in a second. But whenever we create an instance of our class, C# tries to run a special method called the constructor for the class. The constructor has to be named exactly the same as our class name. Notice it says person, person. So that's enough info for us right now. We'll come back to that and get a little bit more as we go. But let's look back at our tester, our program.cs file. Now, when I create this person class and I'm at work, I'm creating a template that is going to apply to every person in our company, whether they're an employee or a child or whatever they are, any kind of person. So I just want to have all of the basic information that belongs to a person in my class. I don't know how the payroll department is going to use this person object. I don't know for sure how the human resources department is going to use this person object, but I know I need to make sure my class is valid. So I have to have a tester for my class. And that's what my program.cs file is behaving as the tester. So this is just something that as a software developer, when I've been being told to create a new class, I can't just put that code together and ship it out. I have to make sure it works. I have to make sure it's valid. So I have to create a tester to test out my class. And that's what this code is doing. We start out on line 18, creating an instance of our person class. So whenever we are creating a new instance, we use the new keyword. After we've created our instance named Bob, we update Bob to say, hey, Bob, your name is actually Bob Smith, and your date of birth is this date and time. And then we are doing a write line command to write that information out about our person named Bob. So now that we have this combined project, let's set it up to debug. On line 18, I want to set a breakpoint because I want to see what happens when I create this new person. I've got my breakpoint set up, so I'm going to try F5, see if it'll run. Now my debugger loads, and sure enough, here I am sitting at line 18 in my code, ready to execute it in my debugger. Well, now this is going to create an instance of my person class. So if I click step into, I should see control switch to my person class. There it goes. So now, because I said I wanted to create a new instance of that person, control is transferred to this constructor in my person class. In my constructor, I said I want to set the name equal to Frank. Here's our person over here. It's named this right now. It doesn't actually care if it's a person. It knows that it is this. I'm going to keep going. Now, I got my Bob person set up. Notice over here in my local variables, I'm not seeing much information about that. But if I mouse over, like Bob Smith, it tells me all sorts of information. I'm going to step into this code. I should see now his name get changed to Bob Smith, his birth date, and then finally my right line. Now, I'm not seeing a lot of information about that over here in my debugger, but as we build this project, we're going to be able to see more. So we wanted to be able to start out here using our debugger, and that's why I wanted to combine everything into one project. So I'm going to continue on and finish executing, and I'm going to find my book, my textbook. Because we're ready to continue on then with our project. Now, do you have any specific questions? I know some of you are like, what are you talking about? That might be a little too broad. But if you have any specific questions, we could talk about them. All right. Here's where we left off. We output our information about Bob, and now they want us to add some different information for our constructor. So they would like to create another person in our main method and then see how we can do that with some different code. So here we are in our main, and after all of our stuff for Bob, I want to add another person. And this person is going to be Alice. But we're going to do it in a little bit different of a format. This time, we're going to say Alice is a new person. But instead of having the open and close parenthesis, we're going to use a body an open and close curly brace. And within the open and close curly brace, we can specify the value of those class attributes. We're going to say name is Alice Jones and date of birth, new date, time, and Alice was born in 1998, March 7th. So up here with Bob, notice we were able to change Bob's name and date of birth by putting the name of our instance, our class instance, which is Bob, and then followed by a dot, and the variable name within our class that we wanted to update. But here with this formatting, we can do the same thing. We just have our properties, our name and date of birth, embedded within our open and close curly brace. So now let's print that one out. I want this same right line statement, so I'm going to copy it. And I'm going to put it right after that closing curly brace. For Alice. Now, I've got to use my Alice variable here because I don't want to print out Bob's name again. I want to print out Alice's and Alice's date of birth. Complaining to me. Says I'm missing a comma. Does anybody see what I've done wrong? Is it telling you the same thing? Same thing but different. Oh, I see. After our closing curly brace for Alice, we need a semicolon. And inside our body, I've not used this type of syntax before. We don't want a semicolon after we give our instance Alice's name. We want a comma, and then we don't want a semicolon there either. Whew, I just had that syntax messed up. Ah, now we've got it. So it is a completely different syntax, isn't it? So within our block here, our Alice block, we've got to have a list of fields separated by commas with no closing semicolon, and then that syntax will be correct for using this different format code. Now we should see some information when we run this time about Bob and Alice. I'm going to turn off my breakpoint because I don't want to stop right now and do the debugger. I just want to see my output. So I should see the message about Bob Smith, and then I should see my message about Alice Jones. Ah, there we go. So what we did here is just expanded our tester. So instead of testing our class with just one instance, Bob, now we're testing our class with two instances, Bob and Alice. So we just see two different types of syntax that we can use. So our different syntax is really important because it's way out there, huh? Now we want to add a new file to our project. We're going to add an Enum type. And an enum is short for enumeration. And this lets us create a special kind of data element in C#. So I want to go back to my Explorer view. And if you want to set up breakpoints to look at the debugger, you know, going back into the person class to create our Alice instance, that's fine. But I'm going to go ahead and get started on creating our enum so we don't run out of time. Now I want to create a new file. So let me do a new file here. In this new file, they want it to be called kind of a long name, Wonders of the Ancient World.cs. So they definitely could have made that a little bit longer for us. Wonders of the Ancient World.cs. Now I need to make this one the same namespace as my others. I have them both in the same namespace now. So I'm going to look at one. I went into my program.cs file, and I think that I want to copy my top using statements and my namespace. File created, okay? All right. Now remember, I've got this using statement commented out. That was what we had to have when we had our separate projects. But since we've combined everything in the same project now, we don't have to have that using statement. So just a little bit differences there. But let's create our enum, public enum. So this is a special thing. Wonders of the ancient world. Now often in C# we get this where our file names and our entity identifiers have to match exactly. And that's the way this particular one is, since it's in its own file. Now what an enum is just a list of things. And in this list of things, behind the scenes, C# is going to assign each thing a numeric value in the list. So our first thing, our value 0 thing, would be Great Pyramids of Giza. So we're going to have this list of all of these wondrous places that are really long. So Hanging Gardens of Babylon. And remember for this one, only you will know if you make a spelling error. Statue of Zeus at Olympia. Temple of Artemis at Ephesus. This one that I've not heard of a lot. These sound like some great places to go, huh? Mausoleum, maybe not, at Halicarnassus. Colossus of Rhodes. And finally, Lighthouse of Alexandria. Whew. Makes you want to do like a Google Earth tour or something of all these wonders of the ancient world places. Now behind the scenes, basically C# is going to assign a code to each of these places, starting at 0. In our next chapter, we're going to talk a lot more about arrays and lists of things. So for now, we just can kind of say, it's going to start at 0, 0, 1, 2, 3, 4, 5, 6 entries. And C# is going to take care of a lot of that behind the scenes for us. So now that we've got this enum created, all of these great places, let's use our enumerated list. That's really all we have here. Let's put a comment in. And we'll say enum enumerated each item is assigned an integer value. So we don't have to worry about that. It'll be taken care of behind the scenes for us. Now that we've got our enum created, we can utilize it. Let's use it in our person class. How's everybody doing with that? You ready? Got it, got it. Got something anyways for all of these different awesome places. Make sure you have the same number of places. And then let's go to our person class and use our enum. All we need to do is add to our list of fields up here. After our date of birth, we'll add public wonders of the ancient world. Did I get it? Thank you. And we're going to call that list favorite ancient wonder. So what we're saying here is that I want to create a new variable called favorite ancient wonder. This variable is going to be an integer value, a number that equates to one of the values in this enumerated list. So now my person can say their favorite ancient world wonder was the Colossus of Rhodes, and we will keep track of that number that is associated with the Colossus of Rhodes here now in our person class. We want to know what their favorite place is, so now we can keep track of that. So let's test it. That wasn't very much to add it to our class, was it? So now we got to add it to our tester. Let's go to our program.cs file. And for Bob, here after we add his birthday, let's set his favorite place, favorite ancient wonder. And notice IntelliSense suggested that, and I was able to just press tab to drop it into my code, so I didn't have to type it again. And I'm going to set his favorite ancient wonder to our whole list, wonders of the ancient world, dot, and then the one that he likes. And he wants the statue of Zeus at Olympia. So now we've got Bob's favorite wonder of the ancient world set in our class. So now we need to add it to our write line statement. Let's add another write line. So I'm going to output Bob's information about his birthday, and then I'm going to do another write line. In this one, it's going to be very similar to that other one. I'm going to specify the format parameter is, have a generic placeholder 0 and then apostrophe S. So it's going to say Bob's once we've replaced that 0 with his name. Bob's favorite wonder is parameter 1. Its integer is parameter 2. It's in there. And then I'll put a period after that last parameter. Now that's my formatting. So then my named arguments, arg0, we're going to use Bob's name, comma, arg1 will be Bob dot favorite ancient wonder, and arg2 we're going to cast as an integer Bob's favorite ancient wonder. So Bob's favorite ancient wonder can be displayed as the numeric or the string value, the statue of Zeus at Olympia, or it can be displayed as an integer if we cast it as an integer. I really don't need the first right line for Bob's birthday, but I'll keep it just to keep track of our output. So now I should be able to run this. I want to add a breakpoint though, again, because here when Bob is created, I want to see if we see any more interaction with our class because of this enum. Let's try it. I'm going to press F5 to run. And we're ready to create Bob. I'm going to step into it. Our constructor runs, setting the name to Frank, and then we update that to be the right name, set the date of birth. Now, our favorite ancient wonder didn't do anything as far as the debugger is concerned, so our enum looks just like any other variable. Now, we've got Bob's birthday printed out. If I step into one more time, I should see his favorite wonder printed out. There it is. So when I use the favorite ancient wonder variable, I get the string value, but when I cast it as an integer, I get the integer value of that enum item. Now I can stop there. I could keep running and see Alice get created, but I'm okay with just Bob. Now we're going to modify that enum a little bit. Before we do, I want to kind of look at it. Our textbook shows it to us here, and they say that right now we're using a whole integer for those values to keep track of, and we could actually, instead of using 4 characters, which an integer takes up in memory, we could actually just split up an 8-bit byte and say each of these different values has a different bit turned on in this byte. So if you look at here in the textbook where they're talking about it, they say, we're going to say that no favorite wonders of the world is none. All of our 8 bits for this one byte would be set to 0. But then if it's this Great Pyramid of Giza, we're going to set this very first 1 bit on. But if it's the Garden of Babylon, we'll set the next bit over on. And then if it's the statue of Zeus, we'll set the next bit over. So notice how they're just using the next bit in this byte to say they like the Great Pyramid of Giza because this bit is turned on. They like the Hanging Garden of Babylon because this second from the beginning that bit is turned on. Well, what if they like both of those? Well, I could have 0, 0, 1, 1. That would indicate Hanging Garden of Babylon and Great Pyramid of Giza. Now everybody look at that for a minute and see how that's working, because that's something that we do really, really often in programming, is saying that, well, if I only have 1 bit on, like the 4-bit here, then that means the statue of Zeus at Olympia is the only thing that they like. But if I also have this bit turned on, they like that ancient wonder place also. So we don't even have to really think about this as being binary. We could just think about these 8 slots as placeholders to decide which place is the favorite place. And of those 8 placeholders, if this placeholder is turned on, they like the Lighthouse of Alexandria. So we're going to change our enum to do the storage this way so that we're just using 1 character of memory, 1 byte, versus 4 bytes for an integer. But it is neat for us to be able to have multiple values because now we can have numbers with multiple bits turned on. Okay, so let's change it to be like this. I want to go back to my enum, Wonders of the Ancient World. And if your tab isn't open, remember you can go back to your Explorer window and find that CS file. And let's change this real quick before our break. So first thing I have to do to change this enum is under my namespace, I have to decorate it. Decorate. Now, decorating means I'm adding some sort of special tag, special code that's within square brackets. And in this case, we're saying that the special flag or decoration code we want to add is that we're going to use this enum as a flag. And that's just what they call it when we have 8 bits that we're going to split up this way. So now, here where we have our public enum, after the name of our enum, we have to specify that this is going to be contained within a byte instead of an integer. The default is integer. And then I'm going to add none up here at the top because I didn't have that before. And this one is going to be equal to 0B to tell the system we're entering in binary. 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. And then a comma, because now our next one comes. So for Great Pyramid of Giza, I want to put my insertion point before the comma, and I'm going to tab over to have this one lined up. And this is going to equal 0B because it's binary. My first 4 bits or half word are all zeros, and then I have 3 zeros and a 1. Now for the Hanging Gardens of Babylon, I'm just going to keep going. It's a bit. The first 4 numbers are 0, then 0, 0, 1, 0. So see how I'm making a pattern with the ones. If it's statue of Zeus at Olympia, will be 4, then 0, 1, 0, 0. So we're just moving that 1 to the left so that it's in a specific, unique position for each value. Now this one should be 4 zeros and then 1 followed by 3 zeros. So now we've used the first 4. We'll set the mausoleum equal to 0B 0001, and then our second half of our byte is going to be all zeros. The Colossus of Rhodes 0010, and then 4 zeros. And finally, our Lighthouse of Alexandria, the very last one, will be 0100 underscore 0000. So we have 1 left, right? We could add 1 more ancient wonder to the world because we have this last little bit left that we could still use. But we basically used up almost all of the possibilities, and it's break time. So let's get back to it. So far, we've been looking at our person class, and our person class, if you notice, is an instance class. When we're working with an instance class, we have to create a new instance of the class before we can address any of the class values. One thing that we've been working with all along without thinking about it a whole lot is this keyword static. And we've seen that whenever we're running from our main method, like if we add methods, no matter what, we had to keep adding that static keyword. We had to put it everywhere. And I said, well, later we're going to find out what that means is compared to an instance. Well, let's go to our person class and let's add a static variable. So we're going to add a static value. So I'm going to use the keyword static. I guess I'll put public first. I think it likes to be first. Public static. And then let's call this our galaxy. I think that's a good name. And our galaxy, oops, I've got to say what kind of data type it is. This is going to be a string. And we'll say that our galaxy is always equal to a certain value. Now, this variable is different from our other variables in our class. Our other variables are instance variables. I'm going to add that in our comments. These are instance variables. They differ for each instance of our class, right? They could have different values. One name could be Bob, another name could be Carol, whatever. We have different values for our different instances. For our static variable, we only have one. It is not affected by instances. So there's only one no matter what. So whenever we're working with an instance variable, we saw that in our main, in our tester, we have to put our name of our instance before the variable name. Well, when we're working with a static variable, we don't do that. Instead, we put the name of our class. So let's see if we can output this galaxy information from our tester. I'm going to go to my program.cs, and I'm going to add it to Bob's right line here. So right now, we've got Bob was born on, and then our parameter for our date. And let's put in the another parameter, galaxy. Now, for our argument 2, I'm going to have to add that. Arg2 should be that galaxy name, but we don't want it prefixed with Bob. Instead, we're going to prefix it with our class name because it's a static variable. There's only one of them, no matter how many instances we have of our class. That galaxy variable is always the same. So not only is it a static value, in this case, we've given it like a default value. Okay, let's run this and make sure that it comes out correct. Oh, I see it. There it is. So Bob was born. So our Bob Smith variable is an instance variable. It changes. The birth date is an instance variable, but then our galaxy name is a static variable. We would print out that same value no matter what person we were talking about. So when we're working with something that's static, we can think of it as only having one value in memory, no matter how many instances are trying to use it. So notice that difference in how we address those variables. For our instance variables, we have the instance name, then a dot, and then the variable name that's in our class. But for a static variable, we have the class name and then the variable name. So a little bit different of syntax, but it helps us to know how things are defined too when we're working with other classes. Okay, questions about that? Because static variables and static values can kind of cause us some trouble, because when we're working with static things that only have one, then we have to be aware of that. You know, we can't have expectations that our galaxy name would be different, because it won't be. So we could actually almost make that into a constant value if we wanted. Let's go back to our person class and see if we could do that. Could we say public constant? Nope, it's mad at me. I can't make it be that many things. So when I have a static variable, I only have one value for the entire class. In our textbook, they talk about making a field a constant value, which is kind of in effect what we've done here. But when they use that const keyword, they say we want to be careful with that. So I'm not really too worried about not being able to do it in our example, because they say constants should be avoided for two important reasons. First, the value must be known at compile time, and it must be expressed as a literal string, Boolean, or number value. Well, we're okay with that. We know what our value is at compile time. But then every reference to the constant field is replaced with the literal value at compile time. So that means that if you make a change in the value, then changes in a future version might not reflect the changes in that value if they're not recompiled to get that reference. So we have to be careful about using constant values within a class anyways. So let's look at making something read-only. Let's go to our person class, and in our person class, I want to add another variable. So I'm going to make this be one of the ones that's above our static. It's going to be an instance variable. So up in this grouping above our static variable. But I want this one to say that it's read only. And I can actually enter that as a keyword. And I'm going to say it's a read only string called home planet. And we're going to default to a value of Earth. So when we set up an instance for Bob, Bob is already going to be in the planet Earth and the galaxy Milky Way, because we have those defaults kind of set. Now I want to go back to our tester to output that home planet information. So let's add it. Right now we have in the galaxy, let's say on the planet 2 in the parameter 3 galaxy. So now I want my galaxy to become argument 3. I moved it. And I need to add in the planet for argument 2. So Bob dot. Now notice how the IntelliSense, when we're looking at Visual Studio Code, is reading our class. It's giving us all of the different variables that we have available to us, so we don't have to remember what all those names are, and we can make sure that we have things set the way we want. Anything that's in this list here is declared as public in our person class. We're being able to access it. I'm going to grab this home planet. That's what I want there in that second argument. Now we should be able to run this and see all of Bob's information. Oops, I've got an error. Let me show it. The best overload for right line does not have an argument 3. It's mad at me. So I'll make it a separate right line because it's just like, you are just doing too much. Let's do right line. And we'll say 0 for Bob. Oh, you know what? I like that. I like the interpolated strings better, don't you? Let's try that instead. We'll just switch it up a little bit. So instead of just printing out these parameters, let's say bob.name. Now remember, I put the $sign before my opening double quote to make this be an interpolated string where I can put the variable name in the curly braces instead of the number. So I'm going to say Bob name was born on Bob.planet, home planet, in the galaxy. Now I'll clean up my earlier one, and I'm just going to get rid of all of this planet and galaxy information and go back to just Bob's date of birth and name. Still mad at me. Let's see if I can run it. Ah, I guess it's too mad at me. Anyways, I don't know why I was getting that weird error. If you notice, once I ran the code and the build process executed successfully, Visual Studio.code got rid of that error. So Visual Studio Code was just a little confused about my awesome syntax there. Thought there was a problem, but there really wasn't. So, you know, sometimes the IntelliSense editor just can get a little bit out of whack. And if we compile and are able to run, it'll realize that it wasn't an error after all. So now I see Bob Smith's name and his birth date, and then his planet and his galaxy, and then his favorite wonder with its integer value. So we're getting everything, all of our information out for Bob. Everybody okay there? You're getting stuff? Everything works?
Question.
Everybody got a problem we can fix, or
Can you hear me at all on here?
issues? Like to get them fixed before we move on, because we're going to start with our constructor for our class, our real one. I put in that fake one just so that we could do some debugging. So I want to go to my person class. But if anybody has a problem, I'd like to fix it first. All right, in my person class, I've been doing some things, you know, we've been slowly creating this and we've just been adding as we go. And there's a few things that I'd like to kind of update to get us sort of all on the same page. First of all, we can use a special compiler directive in Visual Studio or in C# called a region. So I'm going to open up a new line of code right at the beginning of my class, and I'm going to type # region, And then I'm going to put some helpful information here, like instance variables. Now, all of our instance variables go down to including line 15 in my code. So after line 15, I'm going to put #end region. And that's going to end that region of instance variables. Now, I'm going to do a #region right below that. And again, I'm going to put some hyphens and put static variable. We only have the one. I could put an S there either way. And call that a region. And that's only that one line of code. So I'll do my #end region right after it. Oops, I put that in the wrong place. Let me move it. It should be after the actual variable is declared. I'll put it before. Region statements. If we're using the full-blown Visual Studio package, these region statements will cause collapse points. Oh, look, they do in Visual Studio Code also. Notice how if you mouse over towards the line number beside that #region, it has the drop down little arrow. I'm going to click that and see how it'll roll up that whole region now, and then I can expand it back out. So these region statements are really handy for beginning programmers because we're kind of defining the different areas of our class, plus it gives us those roll up, roll down kind of options so we can hide some of the code so that we could focus on a certain area. Okay, so after our static variables, after that end region, I want another region statement, and this is going to be the beginning of my constructors. And we've talked around it a little bit to say a constructor is a special method that is used to create an instance of our class. So when we instantiate that instance, our constructor gets executed. Now I'm going to come to the closing curly brace of our constructor and put my end region statement so that I already have that in place. Now I could have multiple constructors. First of all, I'm going to change this one that's here, and I'm going to delete out the code. And I'm going to put a comment for this one, say that this is a default no arg constructor. Now this default no arg constructor is what C# would create for us dynamically if we didn't have any constructors at all. So last time when we first created our person class, we were able to create that person named Bob without having a constructor in our class, because C# said, oh, you don't have a constructor. I'll just create a default no arg constructor for you. And that's what it looks like. Create a person, but don't do anything. Leave everything about that person blank. Well, what if we want a constructor that adds some other things? Let's say we want to create another one. This constructor is going to set some default values. So again, it's going to be public person. It has to be named exactly the same name as our class name. Same case, same everything. And in this one, we're going to set some default values. You can say name equals unknown. That might be better than what I was just setting it to Fred. Type unknown today. And we'll set our, they want us to have a new variable called instantiated. Should be right under our home planet. Let's add it. public read only date time instantiated. So this is going to be the date and time that this object was created. So let's set that instantiated equals datetime.now. Time.now is just the current date and time. Now, a couple of points here. First of all, our instantiated variable is declared read only, but right here we're updating it. We're setting its value equal to the datetime.now. So this read only variable can be updated by a constructor. But I wouldn't be able to say bob.instantiated equal some other value in my tester, because then I would be trying to update a read-only field. But here I can because I'm within my constructor. Okay, so let's go to our tester now and create this blank person. Right now, I already have a bunch of stuff for Bob and Alice, so I'm going to put this code at the top of my main. My tester is getting a little unwieldy, and that can happen. So let's create one here. Var blank person. Now our blank person is going to be a new person. So let's do a right line statement when we create them. First of all, the format for our right line, 0 of 1 was created at, for parameter 2, we want our date time to be formatted as time. We only want to see the hours, the minutes, and the seconds on a day. Now to continue on my right line, argument 0 should be set to this blank person dot name. 1 should be blank person dot home planet. And argument 2 should be blank person dot instantiated. It's going to end my right line. So I'll put my sum at 1. So I want to see this one first. This should be my first output from my tester. I'm going to leave all the other code in there because it's still valid and still creating good test situations. But I want to see what happens to this blank person now that I have that default constructor. Let's go ahead and set a breakpoint where we create this blank person so that we can watch that code execute, and then press F5 to run. Oh, it's mad about me, my person. What's it saying? Our error message here. It says, I already have a member called person with the same parameter types. Let me see what that means. My default NOR constructor has the exact same method header as this new constructor that's going to add default values. So I don't need this default no-arg constructor. My new default no-arg constructor will be this one that sets default values. So now I should be able to go back to my program and try running it again. And my debugger takes off, and I'm sitting here ready to create this blank person. When I step into, I should transfer control to my constructor in my class. Oop, I got to set some variables first. Okay, now I'm at my constructor. Going to set the name to unknown and the instantiated variable to our current date and time. Now, when we print out information about that person, we should be able to see all of this information. Unknown of Earth was created at 9:47:36 on a Monday. That looks right. So that's the way we formatted our date and time, that we asked for the word of the day and the time. Now, if we wanted to see those values, we could add a watch. I'm going to stop running here. And in this watch area, click the plus sign. And I just want to watch blank person dot home planet. I'm going to put that variable in and say that's something that I want to set a watch on. Now, right now it says that's not available. But if I start running, I should see what happens to that variable. First of all, it's giving me errors. It's like, you're crazy, there's nothing going on there. Well, that's okay, there isn't yet. But when I go into my class, set my home planet variable, and then go through my constructor, we should be able to tell where our home planet is. It's still just giving me errors though. Keep going. I have this one set up for bob.name, and it does actually work. If I keep going, I'll set Bob's name here, and then it does actually show the value. But showing those variables within our classes is definitely a little bit more difficult than seeing our variables that are just local to our tester. Okay, perfect. I'm going to stop running. We've looked at a lot of stuff here. I'm going to turn off this breakpoint. Now, what if we don't want those default names? We'd like to actually allow our code to send us the name when they instantiate the person. Right now, the way we have things set up, we're being able to update the person's name, but we have to do it after the instantiation has occurred. Let's create a constructor that allows us to do that as we're creating the instance. So I want to go to the end of my person constructor that I have in my person class and create a new constructor. This constructor, still public person, but now I want to add some parameters, some values that can be sent as input to my constructor. I want a string that is going to be the initial value for the name, and I want a string that specifies their home planet. Now remember, this is going to be an overloaded method because it's the same name as this pre-existing method, but it has a different signature because it requires these parameters. So in this constructor, we can set the person's name equal to the initial name variable that was passed to us. We can set their home planet variable equal to the home planet string that was passed to us. And finally, we'll set instantiated equal our date time dot now. So now we have a new constructor. Let's put a comment. This constructor requires the person's name and home planet to be provided. So if somebody says they want to create a new instance of a person and they don't put any information within the parentheses, we're going to use this constructor, the default. But if someone says they want to create a person and they supply a couple of strings as parameters, then instead we're going to choose this constructor that has the 2 parameters. So we need to go to our tester and create another person. Let's do it. I'm going to put this person at the very top. This person, we keep using this word var. Notice that we could say this is a person too. We don't have to use that var keyword. I know what class type they are. They're a person class. So let's see. I want to call this one Gunny. And this is a new person. But this time, instead of just having nothing within the parentheses, we're going to say their name is Gunny and their home planet is Mars. Now, notice up here, the IntelliSense is showing you, oh, it looks like you want to use this second version of this constructor. It requires this string and this string. So the IntelliSense is helping you make sure you get that list of elements correct that you want to input to that constructor. We want him to be from Mars. And then let's write out some information about him. In our right line, I'm going to do the interpolated string, and we're going to say that Gunny.name of Gunny.homeplanet was created on. Now we want to put the date time stuff. So I'm going to say instantiated. And I want to do that special formatting. So I want it to be hour, hour, minute, minute, second, second. And then lastly, on a instantiated again, on a long day. Now, do you see a problem with that? I do. This instantiated variable is so long that I didn't put the Gunny dot in front of it. And I still have to have that, even if it's a really long variable name. I still have to say the instantiated value for Gunny. Now, this syntax where I say I want to create a person instead of using that var keyword, that's going to be more common. You're going to see that more often than using the var keyword. The var keyword is like kind of newish in the last few years, so you might not see as much of it being used, out in the wild as you will the actual class name. Now, I want to set a breakpoint when we instantiate Gunny so that I can watch and see how it picks that different constructor. So I'm going to press F5. And here I am. I'm ready to create my Gunny instance. So I'm going to step into, and we set our read-only variable. And now notice that C# has sure enough picked the right constructor. We have the initial name variable already set over here to Gunny, and our home planet is set to Mars. So we're passing that information into our constructor. Now, as we use that information, we'll see that we're going to update the name variable, the home planet, and the instantiated value. That finishes our constructor. We go return control to our tester to do our write line statement, make sure that all of our information comes out properly. Gunny of Mars was created at almost 10 o'clock on a Monday, so that looks correct. So we've done a lot here with our class. We've created variables that have to do with every person. We've set a default constructor for if no values are supplied, we can set up some default values. Then we set up a constructor that actually requires some parameters, some arguments to be passed, and we saw how we could call our constructor that way. So we've just looked at all sorts of different things. But what if we need to set up some actions in our class? Remember, our class has multiple pieces of information. When we were looking at our sphere last time, we saw the variables, the parameters that controlled our sphere, the color, the direction, the speed, those kinds of things that controlled our sphere. Those were our variables. We would have constructors for our sphere that set them up. But then what about our actions? We saw that our sphere needed to be able to perform actions like move and be deleted or whatever. So we have lots of reasons that we might have to create methods within our class. So I'm going to go down to where I have my last end region, and I'm going to put a new # region. And I'm going to say that we have class methods. These are our actions or behaviors of our class. And I'll put my end region here too so I don't forget it. And then I can just start putting what I have in between those two. First of all, we could set up methods to do all sorts of different things, whatever it is that we need to do. Like again, with our sphere, we saw we could have methods that handled collisions with other objects, all sorts of things. Well, for our person object, we have a couple of actions that have been requested. First of all, we would like a write to console method. In this write to console method, we're just going to write out that message about their birthday. Write line, and then we want to use the interpolated string, and we're going to say we want to print out the name was, whoops, my IntelliSense helped me there, was, oops, because I'm missing my double quotes. Name was born on a, I'm going to use my date of birth and the day parameter for that date formatting to just specify what day of the week they were born on. So that's all that write to console method is going to do, their birthday stuff. Now let's do one more. We want another method This one is going to return a string. Our first method was a void method. It's not going to return any data to our caller, but this one is going to return a string. And it's going to be a getter. We sort of talked a little bit about a getter and a setter method, where maybe we want to protect our variables from outsiders. We don't want them to just be public where anybody can change them. Well, then we could use a getter to let other classes know what the values are. Here's one. We're going to return a string. Name was born on, and then their home planet. So we're using our interpolated string just the same way as if we would use it in a write line statement, but it's in a return statement. So we're going to format this string with their name and their home planet, and then return that to our caller. Now we can test these methods really easily. In our tester, we could add these for everybody. Let's put it in for Gunny. First of all, I'm going to say, for Gunny, do that write to console method. Now notice how my new methods are listed here in the IntelliSense, all of the things that we can choose for our instance. I want Gunny dot write to console. And then I'm going to do a write line statement with the output from Gunny dot get origin. So when I call a method within a class, I still have to use the instance to specify. For Gunny, I want to call this method. For Gunny, I want to call this method. Now let's copy those 2 lines of code down here for blank person. Again, I would have to change the instance from Gunny to blank person in both places to get information for blank person. I've still got my breakpoint set on my creation of the Gunny person. I want to leave it like that so that I can run the debugger. As I step into it with F5, what have I done? Show my errors. 47. Oh, it's mad about my ancient wonder thing. I'm going to comment that write line out. Now you guys help me with Visual Studio Code. When I select this and I want to comment it out, is it Control/? Yeah. Because we changed that favorite ancient wonder thing to use those bits, and I haven't updated the tester yet to reflect that. My bad, I skipped that after our break because we had so many other things to do. But now I should be able to try again. Still mad at me. I don't know if I have to save something. Oh, I'm looking at the wrong thing. I was thinking that it was in our tester, but look at it. I'm looking at the wrong place, aren't I? It's saying that this is in what file? person.cs, and I was just assuming it was in my program.cs. It says right there it's in my person.cs file. I just wasn't looking. And it's because I have this write line statement in my class. I always have to remember that I might have to add a using statement in my class using static system.console. We normally don't have a class write out to the console, so that's kind of an unusual thing for us to do, but we can do it, but we have to make sure that we add that using statement. Now, my error disappeared when I compiled again, and I'm in my debugger now, stepping through my code, ready to create my gunny person. So I'm going to step into, it's going to go to our class and run our constructor. Now, I got the constructor run, so I'm going to output some information about gunny here. That's good, we already had that in. But now I'm going to use my new method, write to console, for my gunny instance. So again, we should see control transfer from our main to our person class, write to console method. There it goes. And now it's going to execute that method and return. And now we should again execute our gunny method for the get origin. We're going to return that message and then print it out. So if I do one more step into, we should see all 3 lines of output for gunny. He's from Mars, was created, blah, blah, blah. Gunny was born on a Monday. That was our write to console method. And gunny was born on Mars. That was our get origin method. Now in your textbook, they show you how you can use some tuples or tuples. I say it wrong. And we have a few things that we need to still look at as far as parameters go. So on the trip class that's due March 2nd, this is Wednesday, there may be some things in there that you have to do a little bit more research on. We're going to keep looking at our class when we come back next time. And like I said, we'll try to take a look at some people's implementation of the trip class. So let's see how we are doing there that next time. So work on that. The assignment is actually much simpler than this class we're creating in our textbook. So it's a lot easier. And if you look at some of those training resources that I posted, you should see some step-by-step instructions on how to do that. Hey, Mikey, the read-only is just making it where we can't change that value. You guys get out of here. A lot of hard work today. I'm going to save this again where we are, and I'll post it as a zip file. So if you're messed up or something, you can get it. But they definitely are showing you a lot of challenging code. Woo! So have a great day. I'll see you Wednesday.